Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So here we have been provided with an oblique pentagonal pyramid having edge of the base equal to 30 millimeter and axis height is given to us as 60 millimeter. Now this oblique pentagonal pyramid, it happens to be inclined with respect to the vertical plane as well as the horizontal plane. So to begin with, we have been provided with the information that this pentagonal pyramid has got one of its triangular faces in the vertical plane, and thereafter the edge of the base which is contained by that face, it is making an angle of 30 degree with respect to the horizontal plane. So we are required to draw the orthographic projections of this oblique pentagonal pyramid. So let us first of all evaluate the orientation of this pentagonal pyramid with respect to the vertical plane, such that both of the conditions which are laid out in the problem, so they will be fully satisfied. So the first condition which is available with us, it is that one of its triangular faces, it is contained by the vertical plane. So if we choose this orientation of the pentagonal pyramid with respect to the vertical plane and we incline this pentagonal pyramid with respect to the vertical plane, so then what we are going to observe, this pentagonal pyramid will be resting on one of its corners in the vertical plane. It won't be having one of its triangular faces in the vertical plane. So either we incline it this way or we incline it this way, it will be resting on one of its corners into the vertical plane. So this position of the pentagonal pyramid base into the vertical plane is not acceptable. So it is incorrect. So whereas if we are going to have the vertical plane containing the base of this pentagonal pyramid to begin with into this orientation, what will happen? Now, once we incline this pentagonal pyramid with respect to the vertical plane, so now we can see that this is the location of the pentagonal pyramid when originally the base of this pentagonal pyramid, it is contained by the vertical plane. Then what we are going to do? Now we are going to rotate this particular pentagonal pyramid with respect to the vertical plane by moving the apex from this point. And as we move this apex from this point, and once we incline this triangular face, so once we incline this triangular face in such a way that as we are moving the apex into the vertical plane, so this triangular face will be in turn contained by the vertical plane after the first inclination of this pentagonal pyramid with respect to the vertical plane. So once we have one of the edges of this particular pentagonal pyramid perpendicular to the horizontal plane, so this orientation of the pentagonal pyramid will be good enough to satisfy the condition of one of the triangular faces being contained by the vertical plane over there. And now once we rotate this pentagonal pyramid through its apex such that its triangular face is contained by the vertical plane, then in the second iteration we are provided with the information that the edge of the base, that is this edge of the base, now we are going to talk about. So this edge of the base will be still available as true length into the front view projections over there. Now this edge of the base which is contained by the triangular face which was contained by the vertical plane, so this edge of the base, it is further inclined with respect to horizontal plane at an angle of 30 degree. So this way, using this orientation of the pentagonal pyramid as the base of the pentagonal pyramid will be contained by the vertical plane. So here we are going to have the axis of this pentagonal pyramid will be parallel to the horizontal plane to begin with. So this way, both of the conditions which are laid out into this problem, so they are being catered by this orientation of the pentagonal pyramid. So we are required to draw the orthographic front view as well as top view projections of this oblique pentagonal pyramid, which is inclined with respect to vertical plane in the first instance, and it is inclined with respect to the horizontal plane in the second instance. So here let us proceed with the construction of the orthographic projections of the pentagonal pyramid. To begin with, when the pentagonal base, it is contained by the vertical plane and the axis of the pyramid, it happens to be parallel to the horizontal plane. So here, first of all, we are going to draw the front view projections of this particular pentagonal pyramid when the edge of the base happens to be 30 millimeter. So using edge of the base is equal to 30 millimeter, we have drawn this pentagonal projection into the front view projection, that is onto the vertical plane, and one of the edge of this particular pentagonal pyramid we have taken as perpendicular to the horizontal plane. So we have labeled the 5 corners of this pentagonal pyramid as 1 dash, 2 dash, 3 dash, 4 dash and 5 dash. So let us locate the apex point for this particular pentagonal pyramid. So in order to locate the apex point from each one of these 5 corners, we are going to draw perpendicular bisector of the opposite edge of this particular pentagonal pyramid. So now the intersection of these perpendicular projectors from the different corners of this pentagonal pyramid base, they are going to provide us with the location of the axis point over here, that is O dash and O1 dash. So here O dash point corresponds to the apex point, whereas the O1 dash point, it corresponds to the axis point which is lying on the base of this pentagonal pyramid which is contained by the vertical plane. So having obtained this axis point, now we need to join all these slant edges. There are 5 slant edges which will be apparently visible to the observer when the observer is going to view this pentagonal pyramid from the front view over here. So now we need to join O dash with 1 dash, O dash with 2 dash, O dash with 3 dash, O dash with 4 dash and O dash with 5 dash over here. So this completes the front view projection of the pentagonal pyramid which is having its base contained by the vertical plane. Now let us proceed with the construction of top view projections of this particular pentagonal pyramid when the axis of this pentagonal pyramid happens to be parallel to the horizontal plane and the base of this pentagonal pyramid is contained by the vertical plane. Now we know that the axis length corresponding to this pentagonal pyramid happens to be 60 millimeter. So now we have to draw the projections for the top view projection over here. So in order to draw the top view projections, we can see the axis point O dash and O1 dash has already been evaluated. So from O dash and O1 dash, we have drawn the axis height is equal to 60 millimeter. Now points 1 dash and 2 dash, they will be projected onto the XY reference line as 1 and 2 over here. Similarly, points 5 dash and 3 dash over here, they will be represented onto the XY reference line as points 3 and 5 over here. And similarly, the point 4 dash will be represented onto the XY reference line in the top view projection as point 4 over here. So now we have located points 1, 2, 3, 4, 5 onto the XY reference line because the base of this pentagonal pyramid is being contained by the vertical plane. So the top view projections corresponding to the base, they will be located onto the XY reference line. Similarly, point O1, it will be located onto the XY reference line because this corresponds to the axis point corresponding to the base. Now this axis height we have taken as 60 millimeter. Now we can join these slant edges in the top view, that is O1 and O2, they will be coinciding with each other. O3 and O5, they will be coinciding with each other, and O4 will be represented over here. So here we need to remember one thing, as we are going to look at this pentagonal pyramid from the top. So O dash, 2 dash, this is farther away from the observer. So the top view projection should be drawn as a dotted line corresponding to O2 slant edge over here. But this dotted line or the hidden line projection corresponding to the slant edge O2 has been overshadowed, or it has been superimposed by the object line projection corresponding to the slant edge O dash 1 dash. So the top view projection of O1, it is going to supersede the hidden line projection corresponding to the slant edge O2. Similarly, here once again O dash 3 dash. So this is a slant edge which is lying on the rear side of the observer. Observer is looking at the solid from this side. So this slant edge, that is O dash 5 dash, will be visible to the observer. So now O5 top view projection of this slant edge, this will be drawn with the help of an object line, whereas O3 projection of this slant edge has to be drawn with dotted line or a hidden line. But O5 projection, that is the object line projection, is going to supersede or superimpose upon the dotted line projection of the slant edge O3 over here. So we are going to get the top view projections as they have been shown over here. So now, having developed the front view projections and the top view projections of this pentagonal pyramid, when this pyramid is having its base contained by the vertical plane and the axis of this particular pyramid happens to be parallel to the horizontal plane. Now, in the first iteration, we have been provided with this information that one of its triangular faces is contained by the vertical plane. So now we have to rotate. Please check. This is our apex point. So this is our apex point. Now we have to rotate this particular pentagonal pyramid with respect to vertical plane such that we are going to rotate apex in this direction, such that this triangular face, what is this triangular face? O dash, 1 dash and 2 dash over here. So this is appearing as an edge view into this projection over here in the top view projection. So what we are going to do? Now we are going to rotate this pentagonal pyramid in such a way. This will be rotated in this direction. Please check. This will be rotated. Apex will be rotated over here into this direction. So what will happen? Point 1 and 2, they will be appearing over here, and point O1 will be appearing over here. So once we measure this distance, we are going to measure this distance between O and 1, 2. So we'll mark this point as O1. We have to rotate apex in this direction. So as we rotate apex in this direction, what we have to do? These top view projections of this pentagonal pyramid, they have to be reoriented in such a way that this edge O1 or O2, it should be contained by the vertical plane. The moment we have this edge, that is O1 and 1, 1 and 2, 1. So this represents this particular triangular surface of this particular pentagonal pyramid over here. So now once this edge view of the triangular face, so this is the triangular face which we are able to see clearly in the front view projection over here. So once this edge view we are going to rotate in this direction, so we are going to get this face of the pentagonal pyramid being contained by the vertical plane. So once we mark these 2 points, now you see we know this distance between 1, 2 and 4. We also know the distance between point O and 4. So from this point, that is from 1, 1 and 2, 1, we'll mark this distance over here as distance is equal to 1, 2, 2, 4 distance over here. So this distance we are going to mark an arc over here. Similarly, from point O, this is point O. So we measure this distance O to 4 distance over here. So using this radius, once again, we are going to mark another arc. The moment we mark this arc, so this point of intersection will provide us with the location of the point 4, 1. So using the rectilinear distances, we have been able to transfer this distance between 1, 1 and 2, 1 and 4, 1. And similarly, we have been able to transfer this distance O1, 4, 1 over here. So the moment this triangular figure we are able to obtain now from point 4 or from point 1 or 2, we know the distances of the points O1 and 5, 3 over here. So we can mark this distance between 1, 2 and O1. So the moment we mark this distance over here, we'll be able to locate point O1, 1. Similarly, if we mark this distance between 1, 2 and 5, 3, mark this distance over here. So the points 5, 1 and 3, 1 can be located. Now, same way, now we can darken all the edges over here. So this way, this top view projection of the pyramid, they have been rotated or reoriented in such a way that one of the face of this particular pentagonal pyramid is being contained by the vertical plane. Now what we have to do, having obtained the top view projections of this pentagonal pyramid, now we are required to obtain the corresponding front view projections of this particular pentagonal pyramid. So how that can be done? As the observer is going to look at this pentagonal pyramid from this direction, so here we have got 7 points. So 5 points corresponding to the base, 2 points corresponding to the axis in the top view projections over here. So through these 7 points, we are going to draw the vertical projector lines, and from the previous elevation projection view, again there are 7 points lying over here. So from these 7 points of the previous elevation projection view, horizontal projector lines now we are going to draw. So wherever the corresponding points of intersections they will be obtained, so the front view elevation projections we are going to obtain corresponding to the pentagonal pyramid when one of its triangular faces is being contained by the vertical plane. So from point 5 dash, we draw a horizontal projector line. So wherever it intersects with the vertical projector line drawn through the point 5, 1. So here we are going to obtain the point 5, 1 dash over here. So the next point available with us is 1 dash over here. So through 1 dash, again we draw a horizontal projector line. So wherever it intersects with the vertical projector line drawn through the point 1, 1. So here we are going to obtain the intersection point as 1, 1 dash over here. So next we have got 3 points, O dash, O1 dash and 4 dash over here. So through these 3 points, now we are going to draw another horizontal projector line. So wherever the horizontal projector line drawn through these 3 points, O dash, O1 dash and 4 dash, it intersects with the vertical projectors drawn through the points O1, check, 4, 1 and O1, 1 over here. So the 3 points we are going to obtain over here. So this intersection provides us with the location of the point O1 dash. This intersection provides us with the location of the point 4, 1 dash, and this intersection, check this one, this intersection provides us with the location of the point O1, 1 dash over here. Now the next point we have got 2 dash. So from 2 dash, once we draw the horizontal projector line, so wherever it intersects with the vertical projector drawn through the point 2, 1, so we are able to identify and locate point 2, 1 dash in the front view projection over here. And finally, here we have got the point 3 dash over here. So from 3 dash, once we draw the horizontal projector line, so wherever it intersects with the vertical projector line drawn through the point 3, 1 over here. So here we are going to identify and locate point 3, 1 dash. So all these 7 points corresponding to this pentagonal pyramid, for which one of the triangular surface, it is contained by the vertical plane. So all these points, they have been identified. Now we have to join 1 1 dash, 2 1 dash, 3 1 dash, 4 1 dash, 5 1 dash and 1 1 dash. Also we have to join O1 dash, 1 1 dash, O1 dash, 2 1 dash, O1 dash, 3 1 dash, O1 dash, 4 1 dash and O1 dash, 5 1 dash. But which one of these edges we have to draw using object line? Which one of these edges we have to draw using the hidden line? That we have to understand now. Now, as the observer is going to look at this pentagonal pyramid from this side, so the points which are farthest away from the user, they are 1 1, 2 1 and O1. So all the edges joining O1, 1 1 and 2 1, they have to be drawn dotted, unless those edges, they will be forming the boundary of the solid. So this particular principle we have to remember. So let us join all the edges. Now we can see that we have joined everything dark over here. Why? We should have joined this dotted, we should have joined this dotted, we should have joined this dotted. Why? Because 1 and 2, these points, they are the farthest located point. But we have joined them dark because these edges, they are forming the boundary of the solid. So since these edges, they are forming the boundary of the solid, so these 3 edges we have not drawn as a dotted or a hidden line. We have drawn these edges as object lines over here because they are forming the boundary of the solid. Next, we have to join O dash, 1 dash, O dash, 2 dash, O dash, 3 dash, O dash, 4 dash and O dash, 5 dash over here. So let us join them. So please check O1 dash, 5 1 dash. Again we have joined it dark. O1 dash, 3 1 dash, again we have joined it dark. Why? Because these 2 edges or the slant edges, they are forming the boundary of the solid. So we cannot draw them as a hidden line over here. Similarly, O1 dash, 4 1 dash again has been joined dark over here because this is visible to the observer. This is the nearest slant edge which is facing the observer over here. But when we join O1 dash with 1 1 dash, when we join O1 dash with 2 1 dash, now these are the edges which are covered by this whole body of the solid. So O1 1 1 and O1 2 1 edges, they will not be visible to the observer. So O1 dash and 1 1 dash has to be joined dotted, that is hidden line. O1 dash 2 1 dash again has to be joined dotted, that is hidden line projection over here. So with this, we have completed the construction of the front view projections of this pentagonal pyramid when one of the triangular faces is lying into the vertical plane. Now into this front view projection, one thing we need to understand, this is the edge 1 1 dash, 2 1 dash. This is the edge of the base which is contained by this slant edge. So what is this slant edge? O dash, 1 dash and 2 dash. This was the slant surface over there, slant triangular surface. So into the front view, now you can see in the transformed view, here we have got O1 dash, 1 1 dash and 2 1 dash. So this is the triangular surface which is contained by the vertical plane. So here we have been able to obtain the true shape of this particular triangular surface which is contained by the vertical plane. So these projections are obtained as true shape projections in the front view projection. So 1 1 dash and 2 1 dash. So this edge, we know that the edge of the base contained by that face, which is this face, it is this face, it is this face over here, O1 2. So out of this triangular face, we are now talking about this base edge 1 2. So this base edge, it is further inclined at an angle of 30 degrees. That is, these elevation projections that we have obtained, now we have to rotate it in such a way that we draw an orientation line having angle is equal to theta equal to 30 degree. Why do we say this angle is theta? Because onto this orientation line, the true length of this edge 1 1 dash and 2 1 dash will be lying over here. So now we are required to reorient or rotate or transform this front view projection in such a way that this front view projection has to be reoriented at an angle of 30 degree, while this base edge 1 1 dash and 2 1 dash will be located alongside this projection line which has been drawn at an angle of theta is equal to 30 degree. So how do we just rotate it and put it over here? Now we can see using rectilinear distances. Here we have got this rectangle. So here we have got this rectangle which is going to inscribe this pentagonal base of this pentagonal pyramid. And then once we draw this rectangle, you can see over here, now all the 7 points we have been able to mark using rectilinear distances. So once we draw this rectangle, you can check over here. We have drawn this rectangle. So the longer edge we know. We have drawn the longer edge. We know the shorter edge of the rectangle. We have drawn the shorter edge over here. Now we know the distance of point 1 1 dash from this edge, 2 1 dash from this edge. So 1 1 dash and 2 1 dash can be drawn. So this is 1 1 dash. This is 2 1 dash. Now from this point we know the distance of 3 1 dash. From this point we know the distance of 5 1 dash. So these 2 points 3 1 dash and 5 1 dash we have been able to obtain. And then from this point, this distance will provide us with O1 1 dash. This distance will provide us with location of 4 1 dash. And this distance will provide us with the location of O1 dash. So all the 7 points we have been able to locate over here using the principle of rectilinear distances transfer from this elevation projection view to this reoriented elevation projection view. Now having located these 7 points, now the same way as the different edges they were joined in this elevation view, all these edges they will be joined over here. Now through this we have been able to obtain the front view projection of this oblique pentagonal pyramid, which is inclined to the vertical plane in the first place and it is inclined to horizontal plane in the second place. So now the front view projections of this oblique pentagonal pyramid we have been able to obtain. Now we want to obtain the 7 points corresponding to the front view projections into the top view projection over here. Once the observer is going to look at this pentagonal pyramid from this side, so now projections from all these 7 points we have to draw in the vertical direction, and these projections have to be moved into the top view projection over here. So wherever these vertical projector lines they are going to intersect with the horizontal projector lines which we are going to draw from the previous plan projection view. So the points of intersection of the corresponding points will be providing us with the location of the 7 points in the plan projection view. So let us start with point 41. So from point 41, once we draw a horizontal projector line, so wherever this horizontal projector line drawn through the point 41, it intersects with the vertical projector line drawn through the point 42 dash. So this intersection point of these two projector lines will provide us with the location of the point 42 in the plan. Now the next 2 points they are 51 and 31. So now from point 51 and 31 we have drawn this horizontal projector line. So wherever this horizontal projector line drawn through 51 and 31, it intersects with vertical projector drawn through the point 52 dash, we will obtain point 52. Wherever it intersects with the vertical projector line drawn through 32 dash, we are able to obtain the point 32 over here. Then the next point is O11. So through point 011, again we have drawn a horizontal projector line. So wherever it intersects with the vertical projector line drawn through the point 021 dash. This is 021 dash. So here this intersection will provide us with the location of the point 021 over here. And finally, onto this horizontal line that is corresponding to the triangular face 01, 11 and 21, which is contained by the vertical plane. So if we draw a horizontal projector line over here, now the intersection of this horizontal projector line with vertical projector through 1, 2 dash over here, you can check through 1, 2 dash if we draw a vertical projector line. So wherever it will intersect with the XY reference line, we obtain the point 1, 2. Wherever the vertical projector drawn through the point 2, 2 dash, this point is 2, 2 dash. So wherever the vertical projector drawn through the point 2, 2 dash, it intersects with the XY reference line, we obtain the point 2, 2 over here. So this second point has also been obtained. And finally this point 01. So from point 02 dash, once we draw a vertical projector line, wherever it intersects with the horizontal projector line drawn through the point 01, so this point will provide us with the location of the point 02 over here. So all the 7 points corresponding to the plan projection view, they have been obtained. Now what we have to do? We have to join 1, 2, 2, 2, 3, 2, 4, 2, 5, 2 and 1, 2. And also we are required to join 02, 1, 2, 02, 2, 2, 02, 3, 2, 02, 4, 2 and 02, 5, 2. But which one of these edges we have to draw using object line and which one of these edges we have to join using the hidden line, that we have to understand. Now please check, as the observer is going to look at the solid from the top. So the farthest point is 2, 2 dash. So anything joining 2, 2 in the top view projection, that is anything joining 2, 2 point in the top view should be drawn dotted unless it is constituting the boundary of the solid. So let us join the different points. Now you can see we have joined 2, 2 and 3, 2 as dotted, but we haven't joined 2, 2 and 1, 2 as dotted. Why? Because this is forming the boundary over here. So because it is forming the boundary, so we have joined it using the object line. Because it was lying at a lower level, you can see, while this edge 2, 2, 3, 2, it is farthest away from the observer. So this has to be joined using the dotted line. So now the pentagonal shape we have been able to join. Now let us join 02, 1, 2, 02, 2, 2, 02, 3, 2, 02, 4, 2 and 02, 5, 2. The moment we join all of these edges with the apex, corners of the base with the apex, so this is the shape of the top view which we are going to obtain. And now also we can join axis over here. So axis is 02 and 021 over here. So this is the representation of the axis in the top view projection. So this way we have been able to obtain the front view projections as well as the top view projections of an oblique pentagonal pyramid, in which one of the triangular faces of this pentagonal pyramid, it is being contained by the vertical plane, and the edge of the base which is contained by this triangular face, this is inclined with respect to horizontal plane at an angle of 30 degree. So with this we complete the discussion about obtaining the orthographic projections of this pentagonal pyramid when this pentagonal pyramid is first inclined with respect to the vertical plane and then it is subsequently inclined with respect to the horizontal plane. So this is all for today. So we are going to continue with further discussion regarding few more illustrative cases in the coming lectures. So thank you very much. Thanks a lot.